All right, so this video is going to be about the different characteristics that we're going to look for of a function. And these different characteristics that we're going to use to describe functions, we're going to use to describe all the different functions we're going to study. So this is in the context of absolute value functions, so we're going to look at absolute value functions for the examples, but we will be using these words over and over and over again. So this is kind of like vocabulary terms. So the first two words that we're going to look at should be familiar to you. You should have learned about them a little bit in Math 2. The words are domain and range. So the definition of domain is that it's all the x values, which are the inputs. This is what you plug into a function. These are the inputs that are defined in the function. The range is all the y values, which are all the outputs that you get out of a function. Inputs, this means that you can plug x values into the function and get an answer. So numbers are in the domain if when you plug the number in, you actually get a valid answer on your calculator, you do not get an error message. That's how you know that that x value is in the domain. The range, all the outputs, basically this is the answer that you get after you plug the x values in. The answer you get after you plug the x values in. So these are the actual definitions of domain and range. In upper level classes, they actually use those definitions more. For us, we just have to remember that the domain is talking about the x values and the range is talking about the y values. And in Math 3, we basically think about the domain and range and we use pictures of the graphs to find it. We don't really think about the definitions as much. I mean, the definitions are good to know, but for us when we find them, we primarily are going to look at the pictures of the graphs. So when I look for the domain and range for a problem like example 1, for the domain, I'm going to look at the x values, which means I'm going to look from left to right on the graph. So I'm looking to the left, I'm looking to the right. I can see that all of these values are there, right? Everything's there, there's no gaps, there's nothing that's like missing in the graph. And then I can see that there's an arrow going to the left and there's an arrow going to the right. And those arrows mean that the graph is going left and it's going right forever. So anytime we talk about forever, that's when we use the number infinity, which is not really a number, it's more of a concept, but we'll call it a number. So an arrow going to the left is on the negative side of the graph. So we'll say if we have an arrow going to the left, that's a negative infinity. And if we have an arrow going to the right, that's a positive infinity. So for your domain, if you have an arrow going to the left and an arrow going to the right, we're going to go ahead and write that down. The left side of the domain is negative infinity. The right side of the domain is positive infinity. And so we write down the answer from left to right, and I'm just going to put parentheses around it. All right, now for the range, we're using y values, and so we go up and down. So I'm going to go ahead and look at what the bottom of the graph looks like, and I'm going to look at what the top of the graph looks like. So I want to kind of end the graph in the same place. So it would kind of go like that. So here is the bottom. I'll use kind of a box this time. There's the bottom of the graph. And then here's the top of the graph. Bottom and the top. So the bottom of the graph has arrows going down. The top of the graph has arrows, or doesn't have arrows, it has the vertex right there. So bottom of the graph, the top. The bottom of the graph is arrows going down. So that's going to be a negative infinity. And then the top of the graph is the vertex. And so if we think about the vertex that has 2 coordinates, the vertex here is +3, +2. But if I think in terms of the range, in terms of the y value, in terms of things that are up and down, then the 2, the fact that it's up 2, is the part that I'm interested in. So the bottom of the graph is arrows going down, that's -infinity. The top of the graph is 2. So I'm going to say the range of this is from the bottom to the top. Now, with these graphs, anytime you have a number that you can put your finger on, 2, I can put my finger on it, you put a bracket. We actually can't put our finger on infinity. If I put my finger on the arrow and say, there, Miss Rice, I'm putting my finger on infinity, I'm not actually putting my finger on infinity. I'm putting my finger on -8. So that's not actually infinity. Okay, let's look at the next one. So again, we are doing the domain and the range. That's x and y values. So the domain, we're going to look at arrows going to the left, arrows going to the right. And so for this, we're going to go left to right. So we have a left arrow, we have a right arrow. The left arrow is always going to be the -infinity. The right arrow is always going to be the +infinity. And so that means that the domain is from -infinity to +infinity, from left to right. Okay, now let's go ahead and do the range. We're going to look from the bottom of the graph to the top of the graph. The bottom of the graph is this part right here. That's the vertex. The top of the graph, they don't really end in the same spot, so I'm going to kind of draw that side up a little bit. Okay, so the top of the graph is right here. So I can see the bottom of the graph is the vertex, and the vertex was -4, -7. And so this part right here, the bottom of the graph, was the fact that it went down, it was -7, goes down 7. And then the top of the graph is the arrows going up. So the top of the graph is +infinity. So for the range, we're going to say bottom to top. So -7 to infinity. So I'm going to put a parenthesis around infinity. I can't put my finger on that. If I put my finger right here, I'm like, oh, that's 8, or that's like a y value of 0, but that's not infinity. When I put my finger there, that's not actually infinity. But if somebody says, Miss Rice, where's -7? I can say right here. That's where it is. So if I can put my finger on it, I make it a bracket. Okay. All right, the next one, we have the vertex. The vertex is the point where the graph switches from increasing to decreasing or vice versa. So if you look at these graphs, they're increasing when the graph goes up, they're decreasing when the graph goes down, decreasing when the graph goes down, increasing when the graph goes up. And so the vertex is where the graph switches directions, where it's no longer, where it switches kind of like the highest point, the lowest point. That's what the vertex is. So the vertex is the point where the graph switches from increasing to decreasing, or vice versa. We often think of the vertex as the middle of the graph or the starting point. A lot of people find the vertex before they even get started with the problem, and if they graph the problem, they graph the vertex first. So for a lot of people, the vertex is the starting point of these different graphs. Some graphs don't have a vertex. They don't have a point where it switches from going up to going down, but they still have something that's the middle or something they consider to be the starting point. And so in this class, we're just going to call it the locator point. Because remember, these words don't just describe what we're learning for this unit. They're actually going to be used as vocabulary in all the units that we study after this too, all the other functions that we study. And so it's going to be helpful for us to have terms that are like accurate. So vertex is what we'll use for things that like switch directions like this. And if it doesn't switch directions but still kind of has that middle point, then we'll call it a locator point. The vertex and the locator point are found in the equation using h and k, and you're always going to write that as h comma k. So remember, when you look, the h, it was always x minus h, it was the opposite sign, and so that's why it's written as positive h here, because you do the opposite sign when you write it in the parentheses. All right, next page in the notes. We have the increasing and decreasing interval. So the increasing interval are the x values that make the function. Now, if you think about the function, actually, I'll look right here. Here we could read this as the absolute value function is 2 times the absolute value of x plus 1. We could say that. Or we could just say y equals 2 times the absolute value of x plus 1. So when we read this, we could say the function or we could say y. And that's because the word function is the same as just the y value. The function and y mean the same thing. So aka the y value. So when they ask you a question about the function, they're really just asking you a question about y, which is kind of interesting. So these are synonyms. There's an English word for you. Synonyms, they're the same thing. So increasing intervals are the x values that make the function go up, which for us in the picture just means that the graph is slanted up to the right there. Just means it's slanted up to the right. Right. The next part has a little bit of a typo. Decreasing interval is still x values. Okay. The x values that make the function, aka the y value, go down. This is where the graph slants down to the right. All right, so we just studied domain and range. Domain was, let's look at it. Oh, you see it? Domain was an x value, range was a y value. And now we're looking at increasing and decreasing intervals. These are both x values. So we write down x values a lot more often than we write down y values. Okay, so what I like to do for examples like this is, again, we're going back to the picture because in Math 3 we typically use the picture to help us interpret these things because at this level of math that's where our brains are. In more advanced classes they would have you only look at the equation to find these. So what I like to do is have us use our common sense. And I put a stick figure here because it helps us to use our common sense. So if you put a stick figure, then the graph is decreasing if the stick figure is walking downhill and increasing if the stick figure is walking uphill. So right here, if the stick figure starts walking, he's walking downhill, so this is a decreasing interval. If the stick figure turns around right here at the vertex, then he starts walking uphill, so increasing. And then from there, we just have to label each of the x values that are important on the graph. So where he starts walking, where he finishes walking, and then right here at the vertex where he switches directions. So x values, which means that even though these are arrows that go up, I'm not going to think of them that way. I'm going to think of them as arrows that go left and right. So this is a left arrow, which is negative infinity. This is a right arrow, so it's a positive infinity. And then this vertex is right in the middle at an x value of 0. Okay, so now I can go ahead and write down my intervals. I have the word increasing is between the two numbers 0 and infinity. So I'm going to write down those numbers, 0 and infinity. Now I know I put a parenthesis there. Now for this one, I'm only going to put a bracket if I can put my finger on 0 where he's walking uphill. Now, I can put my finger on 0, but he's not walking uphill on 0. He's just kind of like sitting in the middle. He's like sitting at the bottom of, I don't know, like a ravine or something. So for this one, I have to put a parenthesis because you only put brackets if you can put your finger on it where it's actually happening. So increasing interval means you're walking uphill right there, and right here you're not walking uphill. You're just sitting there. It's like in between. It's not uphill. The word decreasing is in between these two numbers. So I'm going to write negative infinity and 0. And again, like the infinity definitely gets the parenthesis. I can find 0, but I can't put my finger on where it's 0 and he's walking downhill. I can just find 0, but I can't tell that it's downhill right there. So I'm going to put a parenthesis. All right, I'm going to leave the second example to talk about in class tomorrow because it'll probably be good to talk about like a second one where you can like let that information sink in and maybe be able to ask questions. So let's look at the next definition. We have maximum and minimum. The maximum is the location of the highest value of the function. The highest value of the function. Remember, the function means the y-coordinate, or the y value. The minimum is the location of the lowest value of the function. And we write them as a point. We write them as an x and a y coordinate. So example 5 says to draw an example of an absolute value function with a maximum at 3, -2. So I'm going to go over 1, 2, 3, down 2. And this has to look like a maximum, which means that for my absolute value function, it has to be upside down. That's how it's going to look like the highest point on the graph. Now, these graphs don't have a maximum and a minimum at the same time. They only have one or the other. So for this one, I would say that the maximum was 3, -2. I would say that the minimum was none. All right. Now, this video is long enough, so I'm going to stop here. Do not take any more notes. Do not feel like you need to finish the packet. Do not feel like you need to write anything else. The rest of the notes we are going to fill out together in class.